Starting now with the Exosuit humidity measurement sensor. The main target of this sensor is energy saving on drying processes. Drying means you have to evaporate water from the product and then you have to extract it through the exhaust duct. And if you talk about textile or carpet machines, you have around 15,000 cubic meter per air up to 40,000 cubic meter per air, which you have to heat up from ambient air temperature, which is 20-30 degrees, to process temperature, which is 140, 180, sometimes 200 degrees. And this, of course, needs a lot of energy. And of course, you need a lot of natural resources. And by measuring and control with this sensor, average savings of 3,000 to 5,000 cubic meter air per hour are possible. Just to give you a figure, what does it mean if you heat up 5,000 cubic meter air per hour from 20 degrees to 150 degrees? If we calculate 4,000 working hours per year, and if we calculate around €1 per cubic meter gas, by the way, in Germany nowadays, it's much more expensive. But with €1 per cubic meter gas, we reach around €50,000, and this is quite a lot of money. And this is possible to save. In addition, on this example, we also reduce the carbon dioxide of around 150 tons. And this is really quite impressive. Coming to the next sensor, which is the Tds sensor, which is measuring the fabric temperature of the product. And this sensor normally is used on heat treatment processes for curing or heat setting. On a standard frame, normally you can perfectly adjust the air temperature and you can perfectly adjust the speed of the machine. And this is the first step to get a proper treatment of the fabric. But the main parameter is not the air temperature. The main parameter is the temperature of the fabric. And when you have installed several sensors in the machine, that means, for example, if you have a 6-chamber machine, you have one sensor, chamber number 3, chamber number 4, chamber number 5, and chamber number 6. You get a perfect temperature profile of the fabric inside the machine. And when this sensor is linked also to a process visualization from the machine manufacturer or process visualization from the company PLEVA, you also get information what dwell time do you have. That means, for example, you have 190 degrees for 30 seconds. And that means finally you have not to run anymore on experience, or you have not to run anymore with a huge safety margin. You can run your machine on the maximum speed. And this, of course, saves a lot of energy. And finally, it's also much better for the product quality. In addition, of course, if you need less energy, it's very clear you save a lot of carbon dioxide. Another sensor for dryer is our contact measurement. This is our residual moisture measurement sensor. This is mainly used on the exit of a stander, of a dryer, or on the exit of drying cylinders. Normally on this process, when you do some drying, over drying is normally not that dangerous. So normally you run always on a lower speed. But on a lower speed means you waste a lot of energy and you lose a lot of productivity. And a standard frame many times is the bottleneck in the complete production range. And with this residual moisture measurement sensor, you get a real-time information, what is my residual moisture, and so you can run your dryer, for example, the standard frame, on the highest possible speed. And when you talk about drying cans, of course, we control the steam supply. That means we can reduce very much the energy, the steam supply. And just an example over here, we have a lot of feedbacks from customers. 15, 20, 25% more speed is easily possible. And steam savings on drying cans, we talk about 15, 20, 25% less steam what we need. And this is also not only saving of money, this is also a step in sustainability.